Okay, and we're on to the very last question. The short answer, or constructed response number 3. Given the function g of x equals x minus 2 times 3x plus 2 over x plus 4, x minus 2, x minus 6, it asks for some information. First of all, it asks, what are the equations of the asymptotes of this function? So, as soon as we see asymptotes, we know we're talking about a graph. And they've already factored this for you. So that's pretty nice for the most part. So let's start off with, instead of looking at these questions and maybe missing something, let's do the whole problem as we know it, and then we'll answer the questions. So first, let's start off by finding points of discontinuity. We know x does not equal or cannot equal from x plus 4, negative 4, from x minus 2, 2, and from x minus 6, 6. Okay, because we can't have a 0 in the denominator. These are the restrictions on the domain. Now, are these wholes or are these asymptotes? Well, let's see. We know wholes cancel out. We can cancel this x minus 2 with this x minus 2. So this 2 is going to be a whole. Okay, and the other two are going to be vertical asymptotes. So I'm going to go and put that underneath VA and VA. Okay, then we need to find horizontal asymptotes. If you remember, you'd find the highest power and divide by the highest power. What we had, well, we canceled out. We can even do it with this. So we have 3x on top, 3x plus 2, and on bottom we'd have x plus 4 times x minus 6, and my leading coefficient would be x times x, so x squared. So 1x squared and 3x. So we have x squared as the highest power. So we'd have a 0x squared on top in the numerator divided by a 1x squared in the denominator. 0 divided by 1 is equal to 0. So that is our horizontal asymptote. Horizontal asymptote of 0. Okay. So at y equals 0 is our horizontal asymptote, and our vertical asymptotes are at x equals negative 4 and x equals 6, and our whole is at x equals 2. Okay. Now, I'm also going to graph this just so I have it in case I need it. So the original was x minus 2 times 3x plus 2. Now I wrote it like this on purpose because a lot of people are going to do this and put divided by and then write all these in the denominator, these factors in the denominator, and they're going to get it wrong for that. This needs to have a parentheses around it. Anytime you have more than one thing in the numerator or the denominator, you need to put parentheses around the entire thing. So parentheses, x minus 2, parentheses, new parentheses, 3x plus 2, close parentheses, divided by, start a new parenthesis, and then write what there is, which is parentheses, x plus 4, x minus 2, and x minus 6. And I'm going to close the parentheses for x minus 6, and then close the parentheses for the whole denominator. Now I'm going to graph it and see what it looks like. Okay, you see how it's not crossing this line on the ends? That's because that's the horizontal asymptote. It does actually cross it here, but not on the ends. And then we have our vertical asymptotes here and here at negative 4 and positive 6. Okay, so now I can answer my questions. What are the equations of the asymptotes of the function? Okay. Well, I know one is at y equals 0. And then I have x equals -4 and x equals 6. Okay, that was easy now that I've already done all my work. Determine if there are any points of discontinuity. Explain why or why not. Okay, well I know my points of discontinuity are -4, 2, and 6. So I'm going to say -4, 2, and 6 because you cannot have a 0 in the denominator. I'm just going to pull that out of the way. Okay. And then describe the end behavior as x approaches -infinity and as x approaches positive infinity. So I'm just going to take this as x approaches -infinity. And then as x approaches positive infinity. Okay? And here's what we get. So as x approaches -infinity, I know that's to the left. Y is going to approach 0. And as x approaches positive infinity, again y approaches 0. Okay, so on both ends it's approaching 0. And that's it for the whole test.